Okay, so welcome to day 5. This is our beginning of our second week of Science of Baking, and we are going to be talking about wheat flour. Wheat flour is obviously the one of the primary ingredients we use in almost all baked goods. So as we go through talking about this grain, we'll have plenty of different key terms for this chapter. Some of these you'll see are very familiar. Endosperm, germ, and bran are the primary parts of a wheat kernel. We're going to discuss whole grains. We're going to discuss the proteins that are in wheat, things about dietary fiber, and about whole wheat flour versus just what we refer to as wheat flour. The different varieties of wheats. There are different varieties of all grains, so we need to take that into consideration because the flour that we yield from them can be very different. How wheat is then processed. We're going to go through the processing of wheat and what the bleaching and maturing agents do. A bit about enzymes. Enzymes are naturally occurring, but we'll talk about them, what type of enzymes are in wheat. And this term down at the bottom here called alerone and falling number. These are terms really refer to the enzyme activity. And then different types of flours. So let's get into it. Wheat is a cereal grain. We refer to cereal grains as grains that we use to make different foods. It's just a general term, but it's an industry term as well. It's the most widely grain grown in the world, and it's very popular grain in baking because in other grains, if you add water and you mix the water with the grain, you're sure it'll absorb into the grain or into the flour, but what you end up with is most of the time you get porridge. And when you mix with wheat, you get a metamorphosis. Gluten forms, and you get a very strong and stretchy result, much different than other grains. So the wheat kernel itself is made up of several parts, and I won't go over all the different layers that you see here in this illustration about the bran. There's about 9 different layers of the bran, but when it really comes down to it, we have 3 main parts of a wheat kernel. The whole grain of wheat, the whole kernel is called a wheat berry. And within that, we have the endosperm, which is the center of the grain. That's where most of our flour comes from. Bran is the outer coating. The outer coating is used not only as a separate item, a separate product used for texture and flavor and so forth, but it's also ground into whole wheat flour and it becomes part of the whole wheat flour. And then we have the germ, and the germ has a lot of nutritional value, and it's also sold as a separate product. So whole wheat flour is ground from the entire wheat kernel. It's a whole grain. White flour, on the other hand, is primarily from the endosperm, and it's called wheat flour, even though we know it's from wheat, but it's not whole wheat. When it comes to endosperm, when it just uses the center of the grain, then you're only getting part of the grain. These grains are processed in many different forms. They can be cracked, crushed, rolled, ground. Whole grains have the same amount of bran and germ and endosperm as the original grain. Whole grains can reduce the risk of certain diseases. It's been shown that the insoluble fiber that's in grains can really help with our digestion and help reduce the chance of colon cancer and so forth. But we mostly use these different textures, these different types of grinds to create different textured products and different flavor profiles. So the endosperm, this is the part that we use the most. It contains mostly starch. It's embedded with chunks of protein, and the 2 most important proteins that we use are called glutenin and gliadin. And these are the two gluten-forming proteins that when mixed with water is real important here. Without water, you can't get gluten. You just have 2 separate proteins. But once water is added, they become sticky and they stick together and form and bond and form a strong 3-dimensional network of gluten. The wheat germ is basically the embryo of the wheat plant. So basically, I see the germ germinates. It is what would turn into a new plant if we were to plant these wheat berries. You can buy germ toasted. You can buy it in separate containers. Oftentimes they're sold in the refrigerator section. And then there's the bran. It's the protective outer layer of the kernel. In nature, the bran would protect the inner part of the wheat kernel, the germ in particular, to make sure that its seed has a chance to grow. But it's high in dietary fiber, insoluble fiber, so it will go through and just have a lot of good benefits for your digestive tract. It does soften and swell when wet, and it can be purchased as separate flakes. You can add wheat bran to a bread recipe and be able to get a unique flavor profile, a unique texture out of it. So what's flour made of? Well, it's primarily ground endosperm. It's called wheat flour. Key components are starch and gluten-forming proteins. Now, what's in flour altogether? There's a lot going on in flour. We can see by this chart, 71% of flour is starch. There's about 12% protein. This is for a fairly higher gluten flour like bread flour. Moisture is about 14%. Not a lot of moisture. They try to make sure that before they grind the wheat that it has had a chance to evaporate off excess moisture from the field so that it's down to a certain level. There's a certain amount of natural gums that occur in grains. Lipids are fats, very small amount of fats, and ash generally is an industry term we use for minerals. So we have a bunch of different types of wheat. Wheat kernels are classified as hard or soft, and it generally has something to do with the planting time and the botanical species of the wheat. But basically we have hard red winter wheat, soft red winter wheat, hard red spring wheat, hard white wheat, soft white wheat, and durum. Durum is a very unique flour, a unique grain that grows only in certain climates. Here in the States, it's primarily grown in North and South Dakota. It's also grown in the northern parts of Europe, all the way up to Siberia. And it's very high protein, and it's really different than other types of wheat in that it has a very distinct yellow color to it. So when we mill wheat, the grains are very hard to break down. The starch granules in the process, though, are damaged during milling. This helps them more easily absorb water. And generally, flours are coarse and gritty. They don't pack well when they're squeezed in a fist. And they're generally good for dusting the bench. Softer flours, on the other hand, have a lot higher starch content, lower protein content. They absorb water easily, and they generally will pack nicely. The picture on the right shows something like, let's say, cake flour or pastry flour being squeezed in the hand, and it tends to pack together very easily. So when we classify different wheat, we're going to be classifying it based on their qualities. But when we group them together into sellable products, when we buy flour, for example, we buy a flour that's called bread flour or a flour called all-purpose flour. These are specifically formulated by the company, the mills that make them, to fulfill certain standards and fulfill certain expectations that we have as customers. So generally, hard wheat flours, they generally have higher protein, so they make bread and high gluten flour. They form strong gluten. They're kind of gritty to the touch, although when you feel it, you'd say, well, that's not really gritty. But if you really feel it, you'll start to notice it has something of a little bit more of a coarse feel to it. It doesn't pack well, and it's great for yeast-raised breads. And the reason why is because it has a lot of protein and a lot of gluten potential. Soft wheat flours, on the other hand, generally used to make cake and pastry flour. They form a very weak gluten structure. They're soft and silky. They pack when they're squeezed, and they're used to make cakes and cookies. That weak gluten structure, you have to ask yourself, well, if strong gluten is available, why would anybody want weak gluten? Well, weak gluten gives you the ability to have a product that's more tender, that is more delicate, and it makes it such that you're able to have a product that doesn't have all that toughness. Sometimes, like with cakes and cookies, you don't really want toughness. You want it to be soft. You want it to be easy to bite through. So particle size makes a big difference in how these are ground. So whole wheat berries are as big as things, whoops, whole wheat berries are things that are big as things get. And let me see if I can go back. There we go. Cracked wheat and whole wheat flakes are the next level. That's where basically you just crack the grain into pieces. And then there's farina and durum semolina. Now, semolina is referred to as a grind. It's a type of grind that is sort of coarse, about the coarseness of cornmeal. And farina is a little larger. These larger particle items are used to make things like polenta. They're used to make certain types of breads. And for semolina, durum semolina, it's used to make pasta. But they take a while to absorb water because they're larger particles. Then you have different flours. And flours are rated from coarse to fine. And it all depends on what you're going to use them for and what you'd like their texture to be like. So large grain particles take longer to absorb water. If they're really large, like whole grains or cracked grains, they require gentle heating or overnight soaking. And you'll see some bread recipes that call for a soaker. Basically what that is oftentimes either whole grains, seeds, or cracked grain that need time to absorb enough water to soften. We also make sure they have enough water in them so that they don't soak up water out of the dough and make the dough too stiff. So by having them pre-soaked, they're already wet. They're not going to try to absorb water around them. They can be a really good source of enzyme activity, and enzyme activity generally helps to increase all the subtle flavors that we taste in certain breads, and it also helps to make breads a little bit softer. Now there are additives and treatments. If you've ever seen the word enriched flour listed as on the package, what they're doing is by enriching, they recognize that in the process of processing wheat, you lose some vitamins. Vitamins get broken down and they lose some of their potency. So what they do is they add some vitamins back into the flour. They're doing that partly because, mostly because of children. For children whose bodies are still developing and they need a lot of vitamins in their diet, depriving them of those vitamins could cause other problems like vitamin deficiencies, things like rickets and other health problems. So those things are added oftentimes to flours where the vitamins and minerals have been affected. There is natural aging that's taking place with flour. Flour is oftentimes aged for 6 to 8 weeks in the mill. Just air in the atmosphere, oxygen is the additive. You can actually inject oxygen gas into a silo full of flour, and it will help to whiten the flour. Then there are other bleaching agents. Bleaching and maturing agents often are used to increase gluten strength, but also to whiten. So potassium bromate is used in some flours. It's not as common these days as it used to be, but they used to call it a bromated flour. And if you see that, then you'll know they're using potassium bromate. Ascorbic acid, which is vitamin C, and other bromate replacers. Over time, people realized that they didn't like the qualities they were getting out of bromated flours, so the industry found that ascorbic acid is pretty harmless, and it generally does a lot of the same thing that potassium bromate does. There is peroxide. Benzoyl peroxide is used to bleach and whiten. It's really especially used in cake flour. And of course, chlorine gas is used in whitening of cake flour. So what do you get out of these things? Well, oxygen, for example, listed on this chart, it will whiten. It also strengthens the gluten, and it's used in all flours. Potassium bromate generally strengthens gluten, and it's usually used in high gluten flour. Ascorbic acid also strengthens, used in high gluten and some bread flours. Benzoyl peroxide primarily is whitening agent, and it can be used in all flours, although flours that are listed as organic will not have the use of benzoyl peroxide. And then chlorine whitens. It also weakens gluten. It increases ability to absorb water, and it's primarily used in cake flour. And the reason why is because with cake flour, we want the flour to be pure white as the driven snow. That's one of its selling points. So Even though you lose a lot in the process, you gain the whiteness. So let's also take a look at enzymes. Amylase enzymes are a group of enzymes that break down starches into sugars. They're most active on damaged starch molecules, so that really helps with the browning of products. The activity increases during early stages of baking, so what that's going to do is that starches will be converted into sugars, and all starches are really is long chains of molecules. If they're broken into little pieces, they are referred to then as sugars, and those sugars will caramelize, and they will create wonderful browning, and that will give good flavor, good aroma, and really nice appearance to our baked products. These enzymes also provide food for yeast, because if you're converting starches into sugars, yeast eats sugars, and the yeast are really happy. So we get that brown color from baking. It also helps to soften the crumb, which is the interior of the bread, and slows staling, because if we can soften if we can affect those starch molecules, they're going to start absorbing more water, holding onto that water, and that will slow down staling and increase our shelf life. So our bread will last longer. The falling number is an industry term that we use to measure the amylase activity in flour. And for factory level bakeries, it's a real important number to know, because from batch to batch, from truckload or train load to train load, when it comes to wheat, they want to measure that amylase activity so that they know if it's going to be consistent with the last batch they got. And it's very important for product consistency, especially when you're in a factory where they're baking, 50,000, maybe 100,000 loaves a day. For our average baker, small scale bakers, they usually don't worry too much about the amylase activity, except in how it affects fermentation and affects the browning. We can get amylase activity a lot of different ways. We don't have to add it to our flour. One of the things we can do is we can use sprouted wheat berries. We can use soakers. I have several bread recipes that call for a soaker, and it helps to increase that amylase activity, thereby getting all the benefits that we get from enzyme activity, and that we get great flavor, we get great browning, so we get a lot of good things out of that. Diastatic malt syrup. Malt syrup comes from barley, and it's really great for a lot of breads. I don't add a lot. I usually add, let's say, the equivalent of maybe a tablespoon for a whole batch, but the idea is that it's very simple sugars, mostly glucose, that the yeast really respond to. You'll see malt syrup used in soft pretzels. You'll see it used in bagels, bialys. You'll see it used in kolaches. The idea there is to increase yeast activity, make the yeast real happy, and help increase enzyme activity to increase browning. A little bit of rye flour added to a dough can help increase enzyme activity, because rye has a higher falling number than wheat flour does. Untoasted soy flour. Obviously, if you toast the soy flour, it's going to reach a certain level of temperature where it will deactivate all the enzymes, so it has to still be untoasted. Any malted flour going back to that malt syrup, will help to increase that amylase activity. And then there are special dough conditioners you can buy. They're commercial products that you can add, let's say, a certain small amount to a full batch of dough, and it will improve the handling qualities, it'll improve the shelf life, and improve the overall appearance of your loaves. So what enzyme activity that is going on in the dough will be decreased when you increase the amount of salt that's in a dough. We always add salt to dough, so a certain amount of salt, usually between 1% and 2% salt, is going to help to limit that enzyme activity. Baking temperature is increased. When breads are baked at a very high temperature, the amylase activity starts to drop. And also, it'll decrease when the dough has been refrigerated. Now, for a lot of sourdoughs, we do this. We retard the dough overnight in the refrigerator, and that is basically the proofing stage over a course of 8 to 10 hours in the refrigerator. That will help to limit and just slow down that amylase activity. Malted flour. These are grains of barley that are malted or started to sprout before drying and pulverizing. Used for its enzyme activity. It's commonly added by the miller to bread and high gluten flour, but it's also used by bakers in yeast doughs. And that's, like I say, in certain doughs it's called for. I know it's in my bagel recipe, it's in my pretzel recipe, and it works very well to help increase yeast growth. And then dough conditioners. These are usually called dough improvers, and they're multifunctional. Sometimes they have a component that strengthens gluten to give you better volume and a fine interior crumb. It's used oftentimes in large-scale bakeries, and it's also used in frozen doughs because frozen doughs are bought by a lot of restaurants. They'll buy a frozen product that it's already been made. All they have to do is proof it and bake it. And it helps the dough and the yeast survive the freezing process. And there are, believe it or not, some bread companies, especially large ones like Wonder Bread, that try to eliminate the bulk fermentation step in making yeast dough. It does save time, but flavor is sacrificed. So if you've ever tasted Wonder Bread, you know Wonder Bread has like no flavor. It's just basically white stuff that you just put sandwich fillings into. And the reason why is because they've eliminated the bulk fermentation, so there's really very little in the way of flavor. And this is something you may also have heard of called vital wheat gluten. Vital wheat gluten is mostly gluten, so it's about 75% gluten. It's a creamy yellow powder. It's basically the isolated protein of wheat. So what they've done is they've pulled it out and you use it as an additive. It's used oftentimes in a small amount, like 2 to 5% of flour weight, and it's added oftentimes to rye flour, to rye dough, for strength and volume. You'll see it a lot in Sweden, Norway, Finland, and even Denmark, where they make rye breads that are almost 100% or even 100% rye. But to add a little strength and to give it a little bit more elasticity, they'll add some vital wheat gluten. And it really is just to help the dough hold together better. So commercial grades of flour, there are patent flours, and most of our flours are in the patent flour family. They are the more expensive flours. They're the whitest in color, but they usually come from the center here, the dark area, of the endosperm. And that's primarily what we consume in the United States, whether it be all-purpose flour, cake flour, pastry flour, bread flour, all of them are in the family of patent flours. So what happens to all the endosperm and everything from the outside? Well, that's the next one. It's called clear flour. It's from the outer part of the endosperm. It contains the aleurone layer, which is a nutrient-rich layer. It's on the very outside of the endosperm, really close to where the bran is. And because it's a darker color, it's used oftentimes in multigrain breads and rye breads because people don't mind if their bread has a darker color when they're buying those types of breads. So it contains a lot of nutrients. It's very good for you. It has a lot of great fiber. But the thing is that it doesn't look very good if you're trying to make white bread. And Americans tend to prefer, about 60 to 70% of Americans eat exclusively white bread. So then there's something called straight flour. Now, straight flour is becoming more and more popular in the United States, but it's not commonly used, at least on the factory level. On smaller bakeries, traditional artisan bakers are starting to buy, in special order, straight flour, which means it's flour made from the entire endosperm, and oftentimes, a lot of germ and a lot of bran as well, finely ground. They want to use it for the really traditional artisan breads, and it's gaining popularity among the purist bakers who really want to go back to the basics. So what they're doing is they're making breads, even milling their own grain with their own grain mill, and then using that to make specialty sourdoughs. Whether they bake it in a regular oven, or some are even going as far as to use a wood-fired oven, they are trying to get back to where we were 300, 400, 500 years ago when we were making bread. And they really were all flour. 500 years ago, all flour was straight flour. There was no ability to separate it out into different sections. So when you went to a mill, you would go to the miller and you would buy flour. And there was one type. That was it. And you made bread out of it. That's what we refer to as straight flour. So bread flour, one of our most commonly used flours, very strong, has good protein content. It's used in breads, rolls, croissants, and sweet doughs, things that need a lot of gluten. It can come bleached or unbleached. I think the bread flour we buy at the college tends to be unbleached, but sometimes I see batches of bleached flour as well. Artisan bread flour. Artisan bread flour is generally lower in gluten-forming proteins. It has no added bleaching. We'll see this used mostly in artisan bakeries where they want to have something that is organically grown, no additives, no malt added, no special things done to it. So you'll see things like King Arthur flour is a good example of a lot of the artisan bread flours. They have a few different bread flours they sell, and they're generally in the artisan category. There is high gluten flour. Our high gluten flour in the lab will be bread flour, but generally what is labeled as a high gluten flour even has higher protein than regular bread flour, and sometimes is bromated to increase its strength. It's used for things that really need a lot of strength. They're things like bagels, pizza, and pretzels. These are things that really need a real sturdy flour that has a lot of protein and has the ability to withstand the kind of punishment that the dough is going to go through. Pastry flour. This is a lower protein flour, oftentimes used in cookies and pie dough, muffins and cakes. It has a lot less protein in it, and so a lot less gluten, and it also lends itself well to more delicate items that we expect to be soft and easy to bite through. And then cake flour, usually chlorinated, usually stark white, very little in the way of useful nutrition left in it. But the purpose of making it is to make it white as the driven snow. So very weak gluten. Usually when we're using cake flour, we're using a lot of eggs or other things to help build structure. Cake flour cannot be counted on with its low gluten content to be able to make any sort of structure. So it's used a lot in cakes and cookies. Now, all-purpose flour is usually a blend. So you'll find all-purpose flour generally is a mixture of hard wheat flours and soft wheat flours in order to create a blend that would create a reasonable cake or set of cookies or a reasonable loaf of bread. So it has about 10% protein in it. It's a little lower than bread flour, a little higher than pastry flour. Oftentimes it's called hotel and restaurant flour. It usually comes bleached. Sometimes you'll find it unbleached. And if a recipe calls for it and you don't have all-purpose around, all you have is, let's say, bread flour and cake flour or bread flour and pastry flour, you can make a 50-50 blend to approximate what you would get with all-purpose flour. It's used for a lot of things. All-purpose flour is very useful, and that's why they call it all-purpose. Whole wheat flour. We use whole wheat flour sometimes in our bread class. Sometimes it's referred to as graham flour. If you ever wondered about graham crackers are made with whole wheat flour. Many granulations available from coarse to fine, but it's very good for breads, and it is, but it does have the bran in it, right? It has the bran and oftentimes even the germ in the flour. So because of that, it's a little more susceptible to going bad over time, and it's also by itself creates a fairly crumbly bread. So it's used sometimes, most of the time it's used as a part of the bread, but not as the sole flour used in the bread. Now there's what they call whole wheat white flour, which basically means they take whole wheat flour and they grind it even finer. And when they do that, you're getting the whole grain. That I think is the big selling point with whole white wheat flour, is to get a whole grain in the flour, but still be able to get the whiter color. So that's the selling point. And durum flour. We'll use durum flour in certain recipes, but it's basically very yellow. It makes great pasta. It makes great bread. The Italians love making bread with this, and it has a very distinct yellow color. It's from a very hard kernel a fairly large kernel at that, and it's a very high protein content. Protein content on durum, just to give you a comparison, it's usually around 14 or 15% protein, whereas bread flour is usually about 11 or 12. So that extra protein really makes a big difference, and it's a pleasure to use. It's a lot of fun to work with. So what are the functions of flour? Flour has certain functions. One, it provides structure. That's the biggest thing. It provides the basic structure that holds our baked goods together. It's important in all aspects of baking when it comes to forming structure. It absorbs liquids. It's a drying agent, so it will pull moisture, absorb it. The level of absorption in your flour has a big effect on how your dough comes together, or how your product comes together. So you have to kind of know your flour you're going to use and what its individual qualities are. What is it that it will do? Most recipes already call for a particular type of flour, so you don't usually have to guess as to what type of flour to use. But if you were creating a brand new recipe for yourself, you would need to know your flours well enough to know which flour is going to give you the best performance. Flour contributes flavor. It's a nice, mild, nutty flavor. Depends on the flour, but some flours have stronger flavors, like whole wheat flour has a stronger flavor. They also have difference in appearance and a difference in texture. They contribute color. From the different sources of the different aspects of the grain, from the bran layer, which creates a reddish brown color, carotenoid pigments. Carotenoid pigments are yellow in color, but in high amounts they can lean into orange and even red. Carotenoids are naturally occurring in wheat, but you'll notice the word carotenoid, which leads you to believe, okay, well, carrots also have a lot of carotenoid pigments. So do sweet potatoes. These are things that have a lot higher amount of carotenoid pigments. But we see a certain amount of them in there, and that creates a certain distinct color to our products. And then there's the Maillard browning that occurs during baking. The protein in our flour, again, bonds with sugars, and what you end up with is that deep, rich chestnut browning that you get toward the end of baking. Flour adds nutritional value. Flour has natural vitamins and minerals in it. It's very good for you, unless you have certain diseases where you may have certain conditions where you may be sensitive to wheat. Some people can't have wheat at all, and a lot of people with celiac disease, for example, and other things like Crohn's disease can have a real problem with eating wheat. But most people generally have a good tolerance for it. So when we store flour, flour has a limited shelf life of about 6 months. And I found this out the hard way. I left some flour in a flour bin over the summer, went away for the summer, came back in the fall, and I looked at my flour bin and my flour was moving. Basically what happens is there are eggs from insects that land on the wheat out in the field, and even after milling, some of them still are there and they remain. And we get what we call weevils growing in our flour. It's best to buy the amount of flour you think you'll use up in a reasonable amount of time. I try only to buy flour that I know I'm going to use up within about 2 weeks to a month, and then I just buy new. I buy fresh. It's just like when you buy any fresh food. You want to just keep it moving and keep rotating in the fresh. If it sits for a long time, there is a chance that it could go rancid as well. There are natural oils that occur in flour that can oxidize and start giving off flavors. And whole wheat flour is the most susceptible to this because it contains the most volatile oils, and it's more susceptible to going rancid. So when storing flour, you rotate, right? You rotate first in, first out. You don't add old flour or keep old flour at the bottom and add new flour on top of it. Try to use up as much as you possibly can of the old flour before you put new flour in the bin. Store it in a cool, dry place. And then just watch for infestation of insects and rodents. You just want to kind of keep an eye on that. I found, like it mentions here, silky cobwebs are a sign of flower moths, or what we call pantry moths. I was going through a case of chocolate, Hershey's chocolate chips, last year, and I found some little silky cobwebs in the chocolate chips. The more I dug around in the chocolate chips, the more I found, and I realized that they had been infested with flower moths, pantry moths, and I had to throw the 25 pounds of chocolate away. Be very especially vigilant with whole grains. Whole grains are more susceptible. So that's a lot about flour, all in a very short period of time. This PowerPoint is also available non-narrated, so you can go through and look over the material if you like. But we're going to get right into what we're going to do in our lab today. We're going to experiment with how different liquids affect the flour in a recipe for scones. The original control recipe calls for heavy cream. And I want you to experiment with other liquids. How do they affect the finished product? So in the lab, I'm going to make a batch of control recipe with heavy cream. I want you to pick something other than heavy cream to use. In the refrigerator, there will most likely be whole milk, possibly buttermilk. We could use water, and really almost any other liquid could be used in order to create those scones. We're going to see how radically they change the recipe. How important is heavy cream? So the question then is, what liquids are you going to try using? What makes a liquid different from heavy cream, and how will that difference affect the finished product? If you think about heavy cream, and then think about the liquid you're thinking about using, you'll notice that there are some distinct differences. The question then is, what do you anticipate will happen if you use this other liquid? So when we get into the lab, you're going to fill out a lab form and list what you think might happen, but then after the product is made, we'll have a chance to compare and take a look at what everybody's products look like. All right, so we'll see you tomorrow in the lab. Remember to come with your uniform, bring your masks and so forth, and we will see you then.